Good morning, my name is Caitlin Green, and this will be my vlog over the Chapter 7 textbook problems. As you can see here, I have a blank copy of the Chapter 7 textbook problems that I printed out for me to do my work on, and I'll be reading my answers and basically my step-by-step process from my actual paper here. I will go ahead and clarify that whenever we get down to number 4, my scatter plot does look different than it does on the copy that I printed. I'm not really sure why it did that, but I will show my printed copy just so it shows the accurate scatter plot. But with that all being said, let's go ahead and get started. Number 1 says a correlation coefficient of R equals 0.41 is observed between scores of a frustration tolerance and performance on an 8-hour signal detection task. Then ask what percentage of the variability in the signal detection scores can be accounted for in terms of frustration tolerance. So on this one, it's basically asking from what we know about Y, what can we, from what we know about X, what can we figure out about Y? And so I took the correlation coefficient of 0.41 and squared it to get 0.1681. And the reason I did that is because we're trying to find a percent variability. And so once I take the R squared, it's then multiplied by 100 to get us a percentage of 16.81. And that will be our final answer for A. B then asks what percentage of the variability is due to unknown causes. So not from any other predicted variable that we know of in the testing. And so to find the unexplained variance, we take 1 and we subtract that from R squared, just basically to find the other half of the percentage if we had the whole percentage. And so we'll take 1 and subtract that from 0.41 squared. Don't know why I did that. We'll take 1 and subtract it from 0.41 squared, and we will get 0.8319. And then we have to multiply that value by 100 so we can get it to be a percentage. And we find that the unknown causes percent of variability is 83.19%. Then number 2 asks to make a pie diagram summarizing the relationship in problem 1, which just essentially means that I was going to make a Venn diagram. And this is what my Venn diagram ended up looking like. Let's see if I can get it on the screen. So as you can see, the middle part was highlighted because those are where the two variables overlap and account for each other. And on Y, the unknown variability for Y, we put the 83% there. And of course, whenever you make the Venn diagrams overlap, you have to make sure that the Venn diagram is reflective of the actual amount. So it really wouldn't make sense to have a Venn diagram with the middle so widely overlapped on each other on this problem because it's only 16% where the two variables overlap. Then moving on to number 3, it says using the data on the microwave irradiation and litter size, problem 1 of chapter 6, calculate the regression equation for predicting litter size from the intensity of irradiation. So we're going to be making a regression equation for this problem, which I found was easiest to do by splitting it up into about 3 steps or so. So I wrote out my regression equation of y apostrophe, I can't remember which, y prime. Y prime equals to byx plus ay. So the first thing I did was to find by, and to find that, we take the number of variables in the equation and multiply that by the sum of x, y, and then subtract that from the sum of x times the sum of y, and then divide it by the number of variables multiplied by the sum of x squared minus the sum of x to the second power. And the way that ended up looking is that I ended up getting 42 times 1,517 minus 187 times 392 divided by 42 multiplied by 1,065 subtracted from 187 squared. And I ended up getting a negative 9,590 divided by 9761. And I ended up getting a by value of a negative 0.982. And it's really important to make sure that we carry the negative in this problem, because we know from chapter 6 that we're going to have a negative or inverse relationship for the irradiation and litter size. So it's important to make sure that we carry that negative, or else we're not going to get the right answer in the problem. Next, I went and found AY. And the formula for AY is AY equals Y bar minus BY X bar. And finding Y bar and X bar was fairly simple, because we just took the sum of the values for, say, sum of X and sum of Y, and divided that by 42, or the total number of variables in the equation, or in the problem, excuse me. So I ended up giving my Y bar to be 9.33 repeating. And I subtracted that from a negative 0.982 multiplied by 4.452. And then I took 9.33 and subtracted that from a negative 4.371, which I know is quite redundant to subtract a negative, but I just kept it like that just so I was making sure that I was carrying my negative. And I ended up getting an AY value of a positive 13.701. which meant that my regression equation for predicting the litter size from intensity of irradiation was y prime was equal to negative 0.982 multiplied by x plus 13.701. And then number 4 asks to draw a regression line through the scatter diagram obtained in chapter 6, problem 1. So as I had said before, that my values look my tables look slightly different. So I'm going to show you what my actual table was here. The biggest thing is I couldn't figure out how to have the double dots and the triple dots on the table on Microsoft. But to put the regression line on the scatter plot, I simply just took and picked two x values so I could find the corresponding y values, so I could plot those 2 points, and then I made the regression line on the scatter plot based off of the equation that I got, number 3. And then part B is asking that if the rat were exposed to an intensity of 5, what would be the predicted litter size? And that problem is pretty easy to do, because all you have to do is take the regression line that you obtained in problem 3 and put 5 in place of x. And so I ended up getting y prime was equal to negative 0.982 multiplied by 5 plus 13.701. And I ended up getting a value of y prime equaled 8.791. Moving on to the last page, 5 is pretty much the same setup as number 3 was. However, it's asking for a regression equation for predicting irradiation intensity from litter size. So predicting y from x instead of x from y. And so the equation for that was x prime equals bxy plus ax. And I had the same setup as before, where I found bx and then ax, and then put that in my final equation. So for bx, it was the same equation as pretty much by. And I took 42, multiplied that by 1,517, and then subtracted that from 187 times 392, and then I divided that whole line by 42 multiplied by 3942, and then subtracted that from 392 squared. and I ended up getting a negative 9,590 over 11,900, and ended up getting a bx value of a negative 0.805 or 0.806. And like I said, it's important to make sure you carry the negative, because if we don't carry the negative, we're going to get a positive regression line, which would not make sense for this problem since we have an inverse relationship. I then went to predict or to find AX, and that was the same setup as before with X bar and Y bar, and they are the same values because it's the same problem. And so I took 4.452 and subtracted that from a negative 0.806 multiplied by 9.33 to get 4.452 subtracted from a negative 7.519 to find that AX equaled 11.971, which meant that my final regression equation for number 5 was X prime was equal to a negative 0.81Y plus 11.97. Number 6 tells us to find the variance of estimate and litter size for microwave data. And the way that I did that is I took the SY with the 2 above it, point X equation, and which was equal to SY squared multiplied by 1 minus R squared. And the way that I found the SY squared was having EY squared subtracted from EY squared multiplied, or excuse me, by taking EY squared and then subtracting that from EY parentheses squared divided by n, and then I divided that whole set of numbers by n minus 1, because we are trying to find the variance of the data. And I ended up getting 3,942 subtracted from 392 squared divided by 42, and then took that whole set and divided it by 42 minus 1. Which then brings us to the final part of 3,942 subtracted from 3,658.67 divided by 41. And so I got an SY squared value of 6.91. I then took that and put that into the rest of our equation. We already had R from our chapter 6 problems because we found out that it was a negative 0.89. And so we simply took 6.91 and we multiply that by 1 minus, and make sure we keep the negative going, so we had 1 minus a negative 0.89 squared to end up getting 6.91 multiplied by 0.279 or 2079, and we finally got a SY squared point X value of 1.44 for the variance estimate of litter size for microwave data. Then A asks, if the correlation between X and Y was smaller than observed, what would happen to the size of the variance estimate and Y? So as we went over in the videos, as R decreases, the variance estimate of, or the variance of the estimate will increase, because say R is a stronger value. Well, if it's a stronger value, that means that there's less outliers and less chance for it to be anything but a strong linear line. And so that makes sense that as R would decrease, that the variance estimate would increase, because we would have to have more of an estimate of error for a less strong line than we would have for a line of greater strength. So as R increases, the variance of the estimate will decrease because we have a more concrete and more strong line in comparison to one where R was smaller. So this has been my vlog over the Chapter 7 textbook problems. Hopefully everything was explained well, and I hope you have a good day. Thanks.